Okay, today in class, what we're working on is we're going to continue working on section 6.2. We're going to solve by substitution. What I have up here is two examples of two different problems work done by two different people. What this is showing us well, what happens if we have something other than two lines intersecting. So in this particular first example, number 5, we have the x solved for here. And so I'm going to put that value in for the x that's also highlighted there in yellow. So I put it in there. Everything else stays the same. So the only thing that changed is that x disappeared and I put a negative 2y plus 4 in there. Now what I need to do is I need to use the distributive property because parentheses are bad. So I multiply 3.5 times negative 2 to get negative 7y and 3.5 times 4 to get 14. All right, everything else stayed the same. Now let's combine the y's here. So I have negative 7y plus 7y. Well, that's 0. So 14 is equal to 14. Well, that's true. All right, so anytime I end up with a true statement right here, this is true. And since it's true, that tells me that this is that these two lines are the same. That is infinitely many solutions. All right, those two lines line up, fall right on top of each other. They're exactly the same line. Now, this number 6, the second one that we have here, is solve this time. The top equation is solve for y, which really makes it easy for me to do. I'm going to substitute 3x minus 11 in for this y. And that's what you can see is done here. So 3x minus 11 now replaces the y. Minus 3x is equal to negative 13. Well, I combine the x's. That's 0. So negative 11 is equal to 13. Well, this is a false statement. That's not true. Negative 11 is not equal to negative 13. That indicates that these two lines are parallel. So that means that this is no solution. So what I want you to get out of this is if it's a true statement, the left side is equal to the right side with no variable there. Actually, even if it is a variable, if it ends up to be a true statement, variable on the left, variable on the right, or a number on the left, number on the right that is true, then it's infinitely many. That means that there are two exact lines that are falling on top of each other. If when I solve this, I end up with a false statement, and that will have to be a number is equal to a different number, then those two lines are parallel. That's no solution. All right. Now, other ways that you see this, you'll see this used in word problems all the time. This really makes it easier for us to do. So here's how I take care of word problems. The first thing I do is I read through the question all the way through. After I get done reading it, I try to follow exactly what it says here. Identify the variables, write down my two equations, and then I start to solve. So let's go through this one. A concession stand sells two sizes of snack packs. A large snack pack is $5 and a small snack pack is $3. In one day, the concession stand sold 60 snack packs for a total of $220. How many snack packs did the concession stand sell? Well, unfortunately, this question's just asking how many. Well, it sold 60. It tells us that. The question's asking us for how many of each type did I sell. So the first thing I do is I identify two variables. I'm going to go use the variables x and y. You could make those variables make sense to the problem. Choosing letters that just represent numbers choosing letters that represent whatever this is that we're talking about. In this case, because of how I have to do this, I just don't choose x and y. So I'm going to decide that the large snack pack is my x and a small snack pack is my y. Now, when I go through and I want to write two separate equations, okay, one of them expressing the total, the other one expressing the money. Okay, typically, when I read these things, I'm looking for a quantity and a value equation. So how many of each snack pack sizes did they sell? Well, they sold a total of 60 snack packs. Well, they only come in two choices. They come in small and large. Now the next one, I noticed that $5 here, $5 here, $220. Typically, I look through these and I'm looking for numbers and I'm looking for labels. I'm really looking for numbers with the same label. Now, these all three have the same label. They all have dollar signs. So I'm going to assume that this is my value equation. Okay, a large snack pack has a value of $5. A small has a cost of $3. And my profit was $220. All right, so there I go. I have my two equations, and now I'm going to solve these. I don't choose and pick on the top equation here. The reason is because there's no numbers, no coefficients in front of the x and the y to make it more challenging. I'm going to solve for x just because that's what I want to today. So I get x is equal to, and I subtract a y from both sides, negative y plus 60. So I'm going to put that in for this x right here. So 5 times negative y plus 60 plus 3y is 220. Now, parentheses are bad, so I'm going to distribute this. So I'll multiply 5 times negative y, which is negative 5y. 5 times 60 is 300, plus 3y is equal to 220. All right? Now, I start to look at this now. What catches my eye? What do I want to move and mess with first? What catches my eye is I have two variables, two y's on the same side. So let's combine those. Negative 5y plus 3y is negative 2y. Okay, now I'm getting better. So now from here, let's get rid of this 300. Let's subtract 300 from both sides. Okay, looks good. Now let's divide both sides by negative 2. Okay, so I get a y value of 40. So if I go back up here to the top, x plus 40 is equal to 60. Subtract the 40 from both sides. All right, now I have my answers. I got 20 here and 40 here. So what does that mean? They sold 20 small snack packs and 40 large. Oops, I got them backwards. Sorry. Okay, my X was my large. So I'm going to change this to 20 large snack packs and 40 small snack packs. Okay, word problem, word answer. So there's my final answer for this. Now, notice the technique. What I have here on the left is exactly how I solve all these problems. I really don't change how I do them. It does take a little bit more to set it up, but it's going to be done the same way. These two problems, starting with the one on the left. First of all, I notice that this is solved for x. So I'm going to put that in for this x. So 3 times 4y minus y is equal to 77. Let's get rid of parentheses. So 12y minus y is equal to 77. 11y is equal to 77. Divide both sides by 11. 7. All right, so I know that my y coordinate is 7. Now let's put that 7 in for this y. So I got 4 times 7 is equal to x. 28 is x. And that's how I have to do this. Okay, now the next one. The next one, as I do this, it is solved for y as well. So I'm going to put this value in for this y. Okay, so I just substituted in there. That's the first step. I look at this. I want to get rid of those parentheses. So I multiply 5 times everything inside those parentheses. I don't like the 2 x's, so let's put those together. Let's get rid of this 20. And let's divide by 13. X is 3. Okay, so I know my first answer is 3, comma. Let's put that 3. I like to put it in the easiest one. I think the second column, the second one's the easiest. So 3 times 3 minus 4 equals y. 9 minus 4 equals y. 5 is y. Again, trying to follow the same format, trying to do things as similar as I can. I try not to mess with how I do this. It's almost always the same. All right, this one, this one's a little different. As I look at this, it's not solved for x or y. And so now I can make a choice. Which one would I rather solve for? The x? If I solve this bottom one for x, that's fine. If I solve this top one for y, that's fine. Let's just mess with the top one. So I'm going to add 2x to both sides. So I got y is equal to 2x plus 1. All right, let's put that y in for this y. Let's get rid of this by distributive property. So 5x plus 2 is equal to 12 combined. Let's get rid of those 2's. Divide both sides by 5. So I have a 2 comma something. All right, I'm going to put this 2 into one of these 2 equations. It really doesn't make any difference. I'm going to try the top one here. All right, so negative 4 plus y is equal to 1. So add a 4 to both sides. Tells me y is 5. There we go. Okay, and that's it for today. Your assignment is due numbers 1 through 11 odd on your worksheet for 6.2 day 2.